Okay, so we're going to do the notes for 3.5 right now. And what we're looking at is we're looking at polynomials that have the form x squared plus bx plus c. Now, I want you to notice that there is a invisible 1 in front of the x term. That's right here. And first we're going to look at these types of questions before we move on to the more complicated ones. All right? So let's just take a second and expand these two questions 1a and 1b. So just to review, we're going to take the c's, multiply them together, we get c squared. Take the c and the minus 7, and that is minus 7c. And then we take the 3 and the c, that is 3c. And then we take the 3 and the minus 7, and that is minus 21. So now here these two are like, so we're going to combine them. And we end up with c squared minus 4c minus 21. All right. So now let's have a look at the next one and do distributive property again. So 5 times 9 is 45. And then we've got 5 times negative s, which is negative 5s. And then negative s times 9 is negative 9s. And then negative s times negative s is positive s squared. Okay, so you could rewrite it and you could go 45 minus 14s plus s squared. And if you want, you could rewrite it so that you're leading with the squared term. And if you rewrote it, it would simply look like this. Okay? So it should have an equal sign because they're all following each other as I go down. So this is equal to this, and then I'm working downwards. And so there is my answer to expand. Now what we're going to do is we're going to undo what we've done. So if I were to be given this, for example, as a question, and I wanted it to be written out as the bracket form, we have to come up with a way to break that up. Now, we know what the original question was here, right? So we could kind of look at, okay, how did we come up with a minus 27? So what would be the pattern? How would I associate this minus 21 with this question here? What would the relationship be? So how can I relate this minus 27 back to this here? How did we get the minus 27? We multiplied the 3 and the negative 7. Okay, now this here is a little trickier because it's changed, it's morphed, right? We've simplified it. But if I can come up with a relationship with the, can I come up with a relationship for the minus 7 and the 3 to get me a minus 4? How would I do that? What's the relationship there? If you were to look at negative 7 and 3, what's the relationship with that and the negative 4? You sum them together, right? So we simplified it, right? We see the minus 7 and the 3 here. We just combined them and got minus 4. Okay, now we have to do that exact thing with this question. So now it says factor each trinomial. When it says factor each trinomial, we want the answer to look like 2 brackets generally, and we're going to have, let's say, a variable plus a number here, and I'm going to put a smiley face for the number, and a x or something plus a different face, okay, maybe a different number. So that's kind of the pattern of what your answer is going to look like. It's a little funny with the faces, but let's look at the numbers here. So I need to come up with two, I need to look at this here, I need to look at the -8, and I need to look at the 7, and I need to come up with a pattern. So how do I get this last number? What was done with the numbers in the bracket? What was done, if I look back here, what was done with the numbers in the bracket? They were multiplied. So how do I undo a multiply? Divide, or I look for the factors, right? So what are all the factors of 7? So you want to list the factors of the last number. Okay? Or I more correctly, I should say the constant. Constant. Okay. What are all the factors of the constant 7? 1 and 7. Okay. And how can I combine that to make a -8? So I need them, factors of 7, and I need to combine them. I need them to sum up to -8. So how am I going to get that to happen? How can I put these two numbers together to make them add up to -8? Maybe it'll help if I do this. It could either be a plus or a minus, right, for these guys? So that it gives me a few more options. So how would you add them together to get a -8? -1 and a -7? Okay, so then what I do is I have to find the perfect combination that matches my question. So two numbers that multiply to give me 7 are 1 and 7, and they have to add up. So let's write our brackets. So I have 1 and I have 7, but they have to add up to -8. So the only way that can happen is if they're both negative. And then how am I going to get the x squared part? I need x's in the front here. Okay, so now let's verify this, because I think we're at our solution now. So let's see if it's true. So I'm just going to rewrite what my answer was, and I'm going to do the distributive property on. I'm going to multiply through. What's x times x? X squared. What's x times -7? -7x. What's -1 times x? -x. What is -1 times -7? +7. Ah, so that's how I get a negative out here. See, these two numbers are negative. What are these going to combine to be? -8x. I've got my x squared here, and then I get a +7. Ah, is this my question? Yeah. So in order to get a minus in the middle, so you see how I have this minus here in the middle and a plus at the end, what can you tell me about the pattern of the signs here? They are both negative. All right. So do you think do you have any questions about what we've done here so far? Does this make sense? Okay, so can we try this question? So what do we have to do? We have to list the factors. List the factors of what number? -18. Okay, let's include that sign. Let's include that negative, because I want them to multiply to give me a negative number. So what are all the factors of -18? They also have to sum up to what number? Sum up to +7. Okay? So this is where your multiplication skills are going to come in handy, how quick you are, how good are you at estimating. That's what this is all going to depend on, okay? On the brain inside of your brain container. All right, so how quickly are you able to list, and how fast are you able to get to that number? So let's do that. Let's just on the side make a list. And for now, I'm just going to leave them all positive and then do the negative business in my head. All right? So 1 and 18. 1 times 18, 2 times 9. If I think I get to 1, I can stop. 3 times 6. Is there 4 or 5? No. And then 6, I get back to 6 and I run up the list again. Okay, so these are all the factors that give me 18. And in order to get a negative 18, when I'm multiplying two numbers together, what can you tell me about the signs of it? One has to be positive, the other has to be negative. Right, they have to be opposite signs. Okay, so now think through, which are going to sum up to give you a positive 7? So if I add these two together, I'm either going to get 19, 17, it's not going to happen, right? How about this here? If I add them together just the way they are, I could get 11. If one of them is negative, I could get a 7 or a negative 7. Hey, could this one be it? Yeah? Okay. Okay, so what do the signs of this have to be to get a positive 7? Yeah, which one has to be negative, which one has to be positive? That makes a difference. So the 2 has to be negative, and the 9 has to be positive. So let's have a look here. So then that means I'm going to have A and A. That goes there. And then I'm going to have a plus 9 and a minus 2. So if what is this together? Plus 9? And then what are these two together? Minus 2? So what does this add up to? Does that add up to positive 7a? Okay, and now what do these two numbers, what do the two last numbers multiply to? Negative 18. So that, I think that works. So let's rewrite it, let's just verify it nicely, just so that we can see. So this would be our final answer for that question. This would be our final answer for that question there. So these two multiply gives me a squared, and then I've got negative 2a. This multiplies to give me plus 9a and minus 18. Combine that, a squared plus 7a minus 18. Okay, so if this looks like the question that's given, then you're good. All right, let's have a look at the next one now. So here it's arranged a little bit differently. We're used to seeing the m squared or the squared term in front, and then the middle term with just a one exponent of 1 here from a variable, and then the constant at the end. So for these, you can rewrite them so that it looks a little more digestible. All right. So what's the pattern? What are we going to do? What are we going to look for? We're going to look for two numbers that multiply to what? Negative 30, and sum up to what? Plus 7. Okay? So they multiply to the last number and they add up to the middle term. So let's list the factors of negative 30. And you could stop me when you think I hit it. Okay? So is there a point in listing 1 times 30? No? How about 2 times 15? 2 times 15, do you think that's going to work? No? How about 3, is there a 3 times something? 3 times 10? Could that work? Yeah? Okay, so why do you think this could work? So you're saying plus 10 and negative 3. So we add these two together and we get plus 7, and we multiply them together and we get negative 30? Okay. Looks good to me. I'll buy it. So we need an M and an M out in front. What is this M and M going to give us, other than tasty chocolates? It's going to give us this M squared, right? Okay. And then I can have a plus 10 here and a minus 3 there. So let's just verify this. So this is going to be our M squared, and then minus 3M plus 10M, and then minus 30. Okay, so M squared plus 7M minus 30. So this is our check over here. So we're right. This right here in the box, this is what our final answer is. Okay. So far so good? Okay, let's turn it up a notch a little bit now. Now we're going to look at this question. What can you tell me about this question and how it's different from the previous ones? What do you notice here now? We've got an actual number there now, right? So what we're going to do is we're going to see, is there a common factor among all of the terms? And if so, what is it? So my greatest common factor is actually -5. Okay? So let's take this question here and let's factor a -5 out of every term. So if I take -5 and divide it by this term here, what am I left with? H squared. If I take a -5, divide it with this term, what am I left with? Positive 4H. And if I take a -5 and I divide it out of here, out of the 60, what do I get? -12. Okay. Now I've taken the common factor out. Now what I have to do is I have to factor this trinomial. Okay, so this is a two-step question. So I'm going to do exactly the same. I want to write down my -5 because I don't want to lose it, and then I'm going to end up with 2 brackets as my answer. So on the side here, what are the questions I'm going to ask myself? The 2 numbers that multiply to what? -12 and add up to +4. Okay, so what are the factors of 12? 1 times 12, 2 times 6, 3 times 4. Which one hits the jackpot? The 2 and 6? Okay, what does the 2 have to be? What does the 6 have to be in terms of signs? Okay, why did you choose 6 to be positive? Because? What's your reasoning? Okay, they're going to multiply, they have to be opposite signs, so they're going to multiply to -12. And then why did you choose the 2 to be negative and the 6 to be positive? Because it adds up to +4. Perfect. H and H. Looks good? So now you can multiply this all through to verify that it is the same as the original. So when you check this, what you could do is multiply the 2 binomials together. So you're going to have your -5 there. So you have your h squared plus 6h minus 2h minus 12. And so this kind of brings us back to here, right? And then we multiply our 5 through, so minus 5h squared. This I'm going to say is equal to plus 4h over here in scratch work. And then that's going to be minus 20h, and then the 12 and the 5, they're both negative, so that becomes positive, and then it's plus 60. All right, so let's just square off our final answer so you know what it is. And that's factoring, folks. Okay? So we're undoing what we were doing the other day. So instead of multiplying the two binomials together, we're now factoring them. We're splitting them up into the two things that multiply together to give us our answer. So the questions in the textbook are down here. If there's any reference to algebra tiles and you're not familiar with them from previous lives, then you can just ignore them. Okay?